idea of what you can expect from this course in future lectures. Well, let's start with few basics. First thing is definition. Well, in any subject where we are trying to define something, it is only appropriate that we understand the relevance of the terms that we are using. So here we have two words. One is information and one is system. As I was emphasizing in my last class, the dropping of the word management is not simply cosmetic, but has a profound influence on the way we are thinking on the subject. The subject is not management information system, and it's simply information system. The difference is quite vast, as I am going to explain. Well, let us look at the second half first. This, I hope, since all of you are familiar with, will be the easiest thing to start with. System. Why system? Why are we not calling it as, say, information processing program or information software? Question is, what is the relevance of the term system here? And will our whole discussion change if we don't use the word system? That is what I want to clarify today. System, I hope everybody here understands me. Now, what is system? Yeah. In fact, when we say system, the first thing that comes to our mind is it's not one single monolithic object that we are referring to. And there are many parts. Right? There are many parts which come together to do something. A more academic kind of definition for system is system consists of either subsystems or components. Subsystems again are systems in themselves, but components cannot be broken down into any other. And all this definition you know. So the first thing that we have to understand why we say that it is a system is that we are not looking at, when I say information system is not one thing. So you should not ask me, show me information system. There is no one thing called as information system. Information system is a sum total of many things which comes together and collectively gets the name information system. In fact, that is the meaning of when we said previously also, I think it was not well appreciated. The subject was database management systems. It was not databases. The concern of database is just to know how to manage, create table if you are speaking about relational database. But when I say database management system, I am also interested in how to install, how to take backup of data. All these things were concern of that subject. Unfortunately, that was not done anyway. So the point is, there is a huge difference between the word system and software, which I hope all of you understand. When I say software, I am merely referring to a collection of programs which are taken together to do something. That is software. But when I say system, software is only a small part in the whole discussion. There are many other things. What are the other things? Well, we'll see that. But one thing which is important for us is we should look beyond one component and the collection of components. I am using this particular framework from a long time in different contexts. I hope some of you may recall this, whatever I am going to say now, from your other lectures which I may have delivered. My favorite conception of system is this, that any system, regardless of whether you are talking about system in a very humanistic kind of discipline, sociology and all such areas, also in technical areas. When I say system, there is a particular framework under which I can discuss. Every system necessarily should have three main components. Three main components are system will have three components. No system can exist without these three components. What are they? Right? Now you say, sir, this is block diagram of computer, not system. The block diagram of computer, first year. Actually, computer is also a system. That is why this discussion holds good for computer. If you take any system, think about any respiratory system. Actually the same thing holds good. Take in any mechanical engineering, any machine in this world, any kind of concept of a machine, it will take some input, it will do something and give something. So this is a very standard way of looking at systems. Even educational system, political system, you take any system, this discussion will go. Input, there will be something which you will take the input, process it and use it. So three components we understand are fundamental for any systems. Right? Anything else that are common in all systems? Well, see, this system can work fine. It will take some input, it will do some processing, give some output. Imagine you are designing a kind of machine. For example, say a burner, a stove kind of a system. Input is a fuel, processing is some kind of ignition which will convert that fuel into fire, output will be that energy. We have designed a system using three components. To make the system much more efficient, what is one thing which will be there in every system? There will be a component to control. So, control is mandatory. Right? For example, look at this tube lights. Electricity comes in, it just goes and the output is given. But we have a control switch which controls. So, additionally, any system should have a control component. Now, this control can have a say about the input, process or output. Right? You can either control the input, you can either control the process or control the output. This makes the system much more efficient. One step further, to make the system still more efficient, what is that component which you can add? For example, let us take this burner itself. Burner, now there is a switch which can control the flame, a switch which can control the flow of the fuel, and a switch which can control whatever output. All nice system. If you want to still improve it, what can you do?
Connection.
Huh?
Connection.
The connection is already done, it's all connected. If you want to make the system work on its own, see, this needs manual intervention now. If you want the bulb to glow, you have to put on the switch. If you want to control the flame, you have to do it. If you want to make this automatic, then without human intervention, the system should work. Then what should we do? Very simple. In the burner example, what will a designer do? He will have some kind of sensor, AC. Some kind of sensor will be there. Depending on the output, the system again gives instructions to the process whether to reduce the flame, increase it. Right? This kind of conception holds good for everything. If you want, you can take the same example and think of education system. I leave it to discuss all. So, what we started with 3 simple blocks. To improve it, we have added 2 more blocks. So finally, now we know that any system should have 5 components for a reasonable working of a system. Okay? I hope everybody agrees with this line of argument. other issues that any systems exhibit. Well, see, for example, when we are talking about that same furnace, there are few things which form the part of the system and few things which are outside the system but still influence the system. For example, wind. If you are using this furnace in an open space where there are strong winds, this system will not work. You have to form some kind of other adjustments to work on it. So what I am trying to say is, the entire system can be understood as working within a context. That means, more technically speaking, every system has a boundary, inside which forms the components of the system. Outside is the outside world. Among the issues that are there in the outside world, only few issues influence the system. For example, Barack Obama is the president of USA. Has to do nothing with my furnace. What I am saying is that's outside the system, but it has to do nothing with my system. Right? But one thing I can say, Barack Obama's failure in the climate summit will have a long-term effect on climate change. So winds may blow more strongly after 10 years. So my furnace may come into trouble. That is interesting for me. That means what I am referring to is, in generally what we call as environmental factors. So there are few issues which influence the system, which you should have the ability to identify and take care of. Right? In normal discussions which I do in my business class, I tell my students that business is also a system. Because business also has all these components. Right? Today, we'll keep this discussion here. Now we have understood that systems should have these ideas. We'll come back after some time and see whether what we are calling as information system is really a system. The proving is very simple. If we give a definition of information system now, it should satisfy all these conditions. Then we'll call it a system. Right? Otherwise we'll call it by some other name. So is this concept clear? First part. Now let me come to second concept. This is about system. There is other issue which I wanted to talk about system. One is this. Second is, systems are usually identified by what we call as emergent properties of a system. Those properties which otherwise don't exist, but when you keep something together, when you form that system, the system will exhibit some different property. Those things are called emergent properties. Technically, the default example we give is reliability. Reliability. You get the best of input system. You form the best of processing components, best of everything best. Put them together. You cannot still assure that the final reliability R of the system is the sum total of R1 plus R2, so on, so on. You can't say this. It depends on many other things. Nobody should be surprised about this kind of argument. Because if this was so simple, then you could have a team full of Sachin Tendulkars and keep winning every time. That's not possible. So, just like a cricket team has ability to grow beyond the capabilities of each individual players, a system also grows beyond the properties of each individual components. So system always has emergent properties come into play only when the system is formed. That we should be able to identify. Right? So we shall keep these two ideas with us now. One is that system has these components, and second is system has emergent property. These two ideas will keep aside and focus on the first part of the definition. Information. Right now you should be bored by discussing what is the difference between data, information and yeah, let us hear. With an example. With a very concrete example. How do we distinguish data, information? Very concrete, don't tell me textbook example. Assume that you have to tell your mother what is the difference between data and information. How would you explain?
Data would be like I have some address of some just address, that would be a data. Now if I relate it with an employee or a student, that becomes information for that student. Otherwise that address is just a data. When you relate it to the student, it becomes one information of that student.
All the information is in the form of data, but any data can be any information.
How? How can data itself be information?
Because each and everything can convert it to the data form. Okay. Yeah. But for example, we have one individual data. Okay. With that one, if it's with so many other things, the total thing of this becomes information for some other.
Yeah.
But individual is not.
Exactly. So the idea I think most of you have. By now it should be clear for every one of us that information simply is contextualizing data. Data in a context becomes information. I saw a girl today morning. She came to MSRF. She is a student of information science. She is in X semester. How this becomes information? In the conceptualization given by Pressman, each unconnected data points become information once you start connecting them. Right? This connecting happens in various ways. There is no processing involved because this term processing has been hyped too much. Processing means many people understand it as changing the overall look of the data. It's not that. The same data becomes information for someone else if he is interested in, mainly because it's a timely data, it's in the correct format, it's according to the accuracy and precision which he wants. So the way you contextualize data, it becomes information. Data in a context is information, right? Without going deeper into this idea, let us just conclude that data can also become information if the database context. How do you distinguish between data and information? Collection. In the database terminologies, how do you distinguish between data and information? On a more technical level. Yeah, that's what do that processing tell you? That's why I was very specific in database terms. In database we store data. When does that become information?
Related.
When you run an SQL statement over the relations, the result obtained is information. Can we conclude like that? Broadly, yes. I just saw in the department that most of students here have opted for GIS as open subject. Interesting, because it is very close to whatever we are studying here. It's also a kind of information system. GIS, we often say, is not an information system, but actually I personally have a very strong feeling that GIS actually does not process the information. It helps the user to visualize data in a different way. It actually is a data visualizer rather than an information system. So the same data, for example, a large set of data, say for example the population of different countries or something, listed in a table may not be so attractive. But once you transform the data into some kind of visual format, like you see China and India there and some countries there, you will actually be feeling the sense of the data. Then it becomes information. Right? So you have transformed the data into some way. The transformation in computational term can be different forms. That is what we will be studying here. Then what is the next leap in our area? We do some kind of magic with data and get information. If we play around with information, what do we get? That's what we are into now. Say, continuing the argument that some kind of data after processing becomes information. Start processing information, what will you do? That is continuing the same example. One more set of information is here. And information is connected. Data accumulation becomes information accumulation becomes knowledge. So that's the natural extension of information systems is knowledge management systems. Accumulation of more knowledge, wisdom, accumulation of more wisdom, demands. We are not yet discussing about that. We have somewhere stopped at the knowledge information system. So now we are very much clear that there is something called as information, which is association of different data. And then there is this idea of system, which has components and things like that. How do they come together? How do they come together? There is information, there is system. What is information system? You have understood what is information? So what should be information system? Use these two definitions to give me a definition of information. Okay, a very system.
Information.
So these are all systems. What? Yeah. Think it. Yeah. That's because of the slight confusion. In your formulation, input is information and you want to process information. Right? Information is input and the system will do something and give you something. Adalla. Information is actually the output. So, information system is the system which takes something works in this concept, gives information. That problem. If you had written it here, you would make a system information. Doesn't sound good, so information systems. Right? So now we are very clear. What is information system? So information system is a system. System because we have to make very clear that I am referring to this. So it's a system which takes something. We are not clear what it takes, but let us leave it. But what we know is it gives information. That we know. Clear? Now, let us come and see a kind of brief idea about what actually constitutes an information system. Because as I keep saying, the word information systems means many things to many people. It's hard to give a one-line definition which satisfies everyone. Generally speaking, when you are trying to see an information system, you have to identify whether it satisfies the basic conditions. Andre, what I am trying to tell is, for example, what is the purpose of any definition? What is the purpose of giving any definition? Purpose of giving a definition is somebody who doesn't know, if he sees that, he should know that, oh, this is. Blind man and elephant kateta. Right? Blind man and elephant story is very famous. And blind men try to explain what an elephant is, this has this, this has it. So that next time somebody, you see a new elephant, you say, oh, it has a trunk, it has 4 legs, it has a tail, it has this, big